Hello everyone. Today we're talking all about multiplying and dividing polynomials. Today's an exciting day actually because you're gonna learn a new way of dividing. But what I would love you to do is at the top I want you to try obviously the first review problem. If you remember how to long divide, then if you want to try giving example 2 a shot, you can also do that as well. I will go over that one though by hand. But if you want to give it a shot, just see if you remember it. That would be awesome actually. So pause your video and give those 2 a shot. All right, answer to question 1 is up. You should have got 6x squared minus 3x plus 1. Remember, adding, it's just a matter of multiplying the number that's out in front, distributing it, and then combining anything that ends up being like terms. So when it comes to the next one, long dividing, we have not, you guys probably haven't done this and I don't even know how long. But it's a nice refresher in the sense that it's good to compare and contrast what we're about to do today with what we're going to do in just a minute. But in this problem, it says we're going to take 3,397 and we're going to divide it by 4. So how long dividing, if you don't remember how it works, is you start by, it's really kind of more of a multiplying and then subtracting method. So what we do is we usually start by looking at the first number and we say, okay, does this number on the outside, what we're dividing by, does it go into 3? And since 4 doesn't multiply by any nice number to give us 3, what we do instead is we look at then the first 2 numbers together. So 33, we say, okay, well, what's the largest number or how close can we get to 33? So for example, like if I look at 4 times 6, that gives me 24. I think I can get closer though. 4 times 7 ends up being 28. 4 times 8 ends up being 32. And if I do 4 times 9, I get 36, which is over 33. So we would stop at 8. And 8 is the number, ooh, that didn't turn out all that well. 8 is the number that would go up top. And we would multiply. 4 times 8 ends up being 32. And what we do is we then subtract. So we say, okay, 33 minus 32 ends up being 1. And then we basically repeat the process. 4 can't go into 1. So what happens is we bring down the next number. And we say, well, okay, well, does 4 go into 19? Yeah, not nicely, but again, we look at the largest number under 19 that would work. So like 4 times 4 is 16. 4 times 5 ends up being 20, which is too much. So we're going to just keep it at 4. 4 times 4 ends up being 16. That gets written underneath it. And then we subtract. 19 minus 16 ends up being 3. And we keep going. We bring down the next number. So let's see, 4 times, let's see, 7 ends up being 28. 4 times 8 ends up being 32. 4 times 9 ends up being 36. And if I go 4 times 10, 40 is over 37. So we leave it at 4 times 9, and we write that down and we subtract, which gives us 1. Now you reach the end, you're gonna notice that we can't actually go really any further. There's no more numbers up here that we can bring down. So what happens is this number down here, this represents the remainder. And the remainder, we always are gonna write kind of as a fraction. There's 1 left over that we can't divide by 4. So what we do is we write the remainder over whatever the number it is that we're dividing. Now, you could try this out in the calculator. If you actually try dividing those, if I take 3,397 and I divide it by 4, we get 849.25. And 1/4 is the equivalent of 0.25. Now, I will say though, you're not gonna have to long divide today, technically. I'm gonna show you, there's 2 ways that we're gonna go about today, because up until today, all we've really done is multiply. And that was the first step I was gonna do. I was gonna review just the idea of, the general idea of multiplying. And multiplying is the simplest, one of the simplest things we can do with polynomials. The idea is we just multiply whatever's out in front, and we multiply it through to each piece on the inside. And we multiply like pieces. So 6 times 4 ends up being 24. Y times y squared ends up being y to the 3rd. And then we continue. 6 times 9 ends up being negative 54. 6 times negative 9 ends up being negative 54. Y times y ends up being y squared. And then last but not least, 6 times negative 7 ends up being negative 42. This doesn't have a y, but there's 1 being multiplied through. And we would combine like terms, but there are not. So multiplying is something we've worked with a lot over the course of our Algebra 1 career and really our whole math career. Dividing is one of the things that I don't know if you've noticed, but we never have you do until now. Now is that time when you get to actually go through and learn how to divide polynomials. And there are 2 methods that we use. One of them, you can use long division. I will say this is probably one of the more intense processes if you choose to do the long division route. There's an easier route that was developed called synthetic division, and that's the method that we're ultimately going to use. But I wanted to show you how dividing polynomials is actually pretty similar to numbers. And some students actually really like the long division of polynomials method. Now, no matter which method you use to divide, the key is that you have to add in what's called, I call them fillers. And that is, you need to make sure that your polynomial is in complete descending order. So what we mean by that is, if I notice I have an x to the 4th, and then I skip x cubed and I go directly down to an x squared. When we say fillers, we want to make sure we have every single term represented, no matter if it's in the problem or not. So like for this one, we would have to add in an x cubed term, and we just have 0 of them. It's a filler term. There's a squared term, so that stays. There's a single x, and that one stays. And then there's a number on the end, so that stays. But that's the number that's going to go on the inside. Whatever number you're dividing by, or whatever polynomial it is that you divide by, we're going to go through, and that's going to go basically on the outside. So we're going to have in here, I'm going to take this piece, that's going to go on the inside, and we're going to go through the process, of now long dividing. Now long division kind of works the same way. You start by looking at the first number, and you say, okay, does it multiply by something to give you the first piece in here? And the answer is yes. If I take x times x cubed, that would give me x to the 4th. So we usually write it above, I usually kind of align it with the correct term. So if I'm going to multiply it by an x cubed, it would stay up here. And what goes under here is what happens when we multiply all of these things by x cubed. So x times x cubed ends up being x to the 4th. And 4 times x cubed ends up being 4x cubed. Now the trickiest part about long division isn't necessarily what you do next. It's exactly the same as numbers. You subtract down. So I'm going to subtract a 4x to the 4th. I'm going to subtract a 4x cubed from the 2 terms that are above it. X to the 4th minus x to the 4th cancels, and those are now gone. 0x cubed minus 4x cubed ends up being negative 4x cubed. And then we continue. We bring the next term down, and we say, okay, let's continue. What do I multiply x by to give me a negative 4x cubed? Well, we definitely need a negative 4x. And variables-wise, I have one x here. I want to multiply it by 2 more to get to an x cubed. So that's going to be a 4x squared. And we multiply. 4x squared times x times 4 is going to be what I put down low. Negative 4x squared times x ends up being a negative 4x cubed. Negative 4x squared times 4 is going to end up being a positive 16x squared. And we subtract down. So if I'm going to subtract a negative 4, basically I go through and I just change the signs. That's what subtracting does at the end of the day. So 4x cubed, my negative 4x cubed plus 4x cubed cancels. Negative 3x squared minus 16x squared ends up being negative 3x squared. Oops, it's already out of sign here. Oh no, I just deleted all of that. Nope, all the wrong buttons. That's okay, we'll add it in. So negative 4x squared, it was minus 16x squared. So when we subtract, it switches. So negative 3x squared plus 16 ends up being 13x squared. And honestly, we would continue. And fun fact, you would get an answer at the end of the day. But I'm not going to go too much more into that because this is honestly not the method that we choose. It's long. There's a lot of places that we can make errors. So we don't use that method. To divide polynomials, we actually are going to use a method called synthetic division. So what we do is we start in a very kind of not a similar way, but we kind of align it kind of as if we were going to add and subtract. So in the sense that the first thing that we do usually, and for some reason, I always put it in a box. That's how I learned it, I guess. But whatever it is that you're dividing by, whatever the factor is, we pull out whatever the 0 would be. So really we'd say, okay, x plus 4, set that equal to 0, solve. So I would subtract 4 to both sides, x equals negative 4. Whatever the 0 is, that's the number that's going to go in that little box. Now, how you fill in kind of everything else is we look at the numbers that were over here. So we look at exactly the same thing. We look at the fillers of what our equation was. Oopsie, sorry. So, but we don't actually even use variables. It's one of the reasons why synthetic division turns out to be pretty nice, because all we really use are the numbers from the equation. So in front of the x to the 4th, we have a 1. In front of the x cubed, we have a 0. In front of the x squared, we have a 3. In front of the x, we have a 4. And then the last number also comes down. So this is how synthetic division starts. It's not super exciting, actually. How we start is we start by bringing the first number down. And how it kind of follows somewhat of a little bit of the same process in that your first step is always multiplying, which sounds kind of odd. We take whatever's numbers down here, we multiply it by whatever's up here, and it gets filled in here. So for us, we would take negative 4 times 1, which is negative 4, and that's the number that gets filled in here. Now, the nice thing about synthetic division is you don't have to worry about, do I add, do I subtract? It's always add down. So I don't have to worry about flipping any signs. It's simply just 0 plus negative 4, which just ends up being negative 4. And then we repeat. The number down here, we multiply by what's up here. So negative 4 times negative 4 ends up being 16. And that gets placed up at the next spot. And you add down. If I take negative 3 plus 16, we're going to end up being at 13. And we keep going. Negative 4, now I'm going to take negative 4 times 13, which ends up being what, negative 52. And then we add down, which ends up being negative 48. And last but not least, negative 48 times negative 4 ends up being 192. And we add down, which 192 minus 10 ends up being 182. Now you're probably saying, Ms. Hardy, that's not a polynomial. Like, where did all the x values go? Well, now what we do is we fill them in. And here's where you can actually kind of start to see some similarities. Now, I didn't finish the problem, to be fair, but look at what the first numbers were. When you divide, what happens is whatever degree we start with, what happens is the degree reduces by 1. Because I'm dividing out one of the factors. Essentially, I'm dividing out one of the x's. So here, long division, if my highest degree was an x to the 4th, then what these numbers become are the coefficients of my new polynomial. But we reduce the degree. So that becomes a 1x cubed, a negative 4x squared, a 13x, a negative 48, and here's where you're like, Ms. Hardy, but there's an extra number. I can't go with there's no more variables to take away. So what this last number represents, this is the remainder. And just like long dividing, we take the remainder and we divide it by, and we put it over whatever it is we're dividing by. Now, like I said, we didn't finish long division, but look at the beginning. We had x cubed minus 4x. Look at what we had here. X cubed minus 4x squared. If we had continued, we would have gotten the rest of this polynomial. We're not gonna end up long dividing. We are primarily going to use synthetic division just because it's a way simpler process, honestly. So let's do some actual practice problems. Let's do one more. So we're going to divide the polynomial x cubed minus x squared plus 4x minus 10, and we're going to divide it by x plus 2. So again, when we start synthetic division, we start by finding the 0. So I'm going to solve for x. We're going to subtract 2 to the other side. And synthetic division, -2 is going to be what goes in the little box. Do you have to put it in a little box? No, I always do, just so you know what I'm doing. So now we're going to look through our polynomial. Now we do want to do a quick check just to make sure we don't need any fillers. So my highest is an x cubed, so it should go x cubed, x squared, x number, and we're in luck because that happens here. If we would have gone like x cubed, x number, we would have had to input a 0x squared, but we don't. So all we do now is we pull out the coefficients with signs. So the first number is going to be a 1. Second number is going to be a -1, +4, and last but not least, -10. Now, it doesn't look all that exciting, but remember how we start synthetic division is we bring down the first number. And then basically the rest of the process is multiply, then add, multiply, then add. So you take whatever's down here, multiply it by this guy. So -2 times 1 is -2. And then we add down. -1 plus -2 ends up being -3. And then rinse and repeat. The whole goal is we multiply and then add. This is basically the whole process. Let's multiply. -2 times -3 ends up being a +6. And then we add down to get 10. Then we multiply and add. 10 times -2 ends up being -20. And then we add down to get -30. And now we have our polynomial. But remember, if we started with an x cubed, we reduce by 1. So this becomes a 1x squared minus 3x plus 10. And this number right here ends up being our remainder. So that number gets placed over whatever it is that we're dividing, which is x plus 2. Okay? Now, some people, when they write this right here, some people write this as a factor out front. Like, they'll write it out like this. Because essentially what you're doing, you're dividing it out. We just mean that x plus 2 actually is, well, technically on this one, it's not a factor, but we're going to use that actually now. Synthetic division is super helpful in actually finding zeros. So we can check to see if a number actually is going to be a factor or not. So that's what we're going to do on this first one. It says factor the polynomial completely, given that x minus 4 is a factor. Now, we don't really know too well how to factor exponent or polynomials that have a degree higher than 2. We are eventually going to talk about how to do that, but we haven't actually learned that process yet. So how we start this though is if I know something's a factor, we can divide it out right now. But you do have to know how to divide polynomials, and that's the purpose of today. So as a rule of thumb, remember we always kind of switch the sign in a way if you think of it that way. So this piece right here, technically you could go through and solve, add 4 to the other side. X equals 4, 4 is the number that's gonna go up here. And now we're gonna go through and pull out our polynomials. Now I check for if I need fillers. I have an x cubed, x squared, x number. I don't need fillers, so I'm just gonna pull out all of the coefficients of each of those numbers. And remember, we start by bringing this guy down and we multiply and add. So I actually want you guys to try this one. I'm gonna have you pause your video and I want you to see if you can finish solving this one. All right, you should have gotten x squared minus 2x minus 3. And this one actually is kind of odd in that we have actually a remainder of 0. And that just means that this factor divides it super nicely. It's kind of like if we were to divide like 100 by 10. I'm going to do this long division wise just to show you, like, for example, how this works. So like 10 times 10 ends up being, or 1 times 10 ends up being 10. We subtract, we get 0. And then 10 times what gives me 0? Well, 10 times 0. So in that case, if you do 10 times 10, or whatever, when we go ahead and multiply, that's something where if it divides in nicely, it won't have a remainder. But the directions did say factor completely. So usually, even though we don't know how to factor something that's raised to the third power, right now I know for a fact that x minus 4 is currently a factor. Now, that doesn't mean, but here, do I know how to factor things that are raised to the second power? Of course we do. Since our a value is 1, let's go through and just solve this by guess and checking. What times what gives me x squared? Well, x times x. What multiplies to give me negative 3 that also adds to give me negative 2? Well, the only factors of negative 3 are 1 and 3. And to make it negative, but also add to give me negative 2, that just tells me that my 3 has to be negative. Because negative 3 plus 1 gets me my negative 2, and 1 times negative 3 gets me negative 3. So these are the numbers that are going to go on the inside. And you have your fully factored polynomial. Okay. Now I am going to have you try example 6, which again, this is really kind of just a different way of asking the same question. It says find the other zeros of f given that f of negative 2 equals 0. Now remember, function notation, this is basically just telling us that when x is negative 2, y is 0. It's just saying x equals negative 2 is a 0. And that's the number that's going to go in here. So the way they give you that piece of information could vary, but function notation is just another common way that they'll give you the 0. And that's the number that goes here. So I want you guys to try this from here. So pause your video and now give this one a shot. All right, after synthetically dividing, you should have got x squared minus 9 as your answer. So now we can continue factoring basically. For this one I started, if I do x times x, that's what gives me x squared. Now here's kind of odd. What multiplies to give me negative 9? That adds to give me 0. There is no x term on this one. Or there's 0, but at the end of the day, we're saying what multiplies to give me negative 9 that adds to give me 0. Well, the only factors that can get me there are 3 and 3. And we make one of them negative. Negative 3 plus 3 is 0, and negative 3 times 3 ends up being negative 9. So those are the numbers that go inside. Now, just remember that usually whatever this number is, if you want to put it back as a factor, you just have to remember to switch the sign, right? Like over here, x minus 4 was a factor, so positive 4 is what goes in here. So here we're kind of working our way backwards. So if negative 2 was the number that we were dividing by in synthetic division, then x plus 2 had to be a factor. And the rest of it factored. Whoa, I'm sorry guys, I said as 9. I totally meant as 3. Woo, that would have been bad. All right, I said the right thing, wrote the wrong thing. But at the end of the day, that is your factored form. All right. So for number 7, this one, these are really the only kind of word problems that we're going to deal with for right now. And it says, you are given an expression for the volume of a rectangular prism shown. Find an expression for the missing dimension. So for this one, you guys are in luck because I gave you 2 factors. So if we had to find out what's left, if I'm trying to find out what the last one was, then we're going to use both of those 2 known quantities. And that just means we're going to perform synthetic division twice. So let's do it with the bottom one. Let's do x plus 6 first. So if I'm going to do x plus 6, that just means in synthetic division, negative 6 is the number that we're going to use. And I'm going to pull out all of my coefficients. Now again, just double quick check. Make sure that we don't need any fillers. X squared, or excuse me, x cubed, x squared, x number, we're good. So pull out all of our numbers, 1, 13, 34, and negative 48. And we're gonna divide, synthetically divide, which really involves no division, ironically. So we bring down the 1. 1 times negative 6 is gonna end up being negative 6, and we add down. 13 minus 6 is gonna end up being, or 13, yep, 13 minus 6 is gonna end up being 7. And then we pretty much keep going. Negative 6 times 7 is gonna end up being a negative 42, and we're going to add down. So now we add down. 34 minus 42 is gonna end up being negative 8. And now we multiply and add down. Negative 8 times negative 6 is gonna end up being a positive 48. And then when we add down, we get a remainder of 0. And again, remember guys, when we divide, if we know something's a factor, the remainder should be 0. So if you don't get 0 on something like this, that usually means that you probably did one of the multiplying or adding down steps wrong. Now, technically I have my equation right now. It's gonna be a 1x squared plus 7x minus 8. Now you could choose to go ahead and factor that right now if you want to. If you want though, we also know another factor on this one. Could you use those coefficients and just divide again? Yeah. So if you prefer factoring, you can do factoring from here. If you want to use synthetic division, I'm going to use synthetic division just to give us a little bit more practice. So since it's a minus 1, I'm going to put a plus 1. And these become my coefficients. We have 1, 7, and negative 8. So let's start by bringing it down. 1 times 1 ends up being 1. And we add down. 7 plus 1 ends up being 8. And 1 times 8 ends up being 8. Negative 8 plus 8 ends up being 0, which is my remainder. And this ends up being my polynomial. Now it came from an x squared. So if I reduce the variables, that just means we have an x and a number. And you just found the missing dimension. X plus 8 is the missing dimension. That's what you would multiply by x plus 6 times x minus 1 to get my volume for this rectangular prism. Alrighty. So guys, there are a couple U try nows on the back. If you want to give some of them a go, feel free to do so. We are going to do 1 or 2 of these as a review together. All right. All right, guys, you may start working on the homework.